I'll talk about when human science lifts human spirit. And I'll begin with the demonstration. On the screen, you see a hat with some colors on it. In the front, you'll see that there is a sort of a yellowish rectangle, and on the side, a brownish one. So yellowish and brownish. Are they the same conscious experience or different? They seem to be very different conscious experiences, right? But in fact, I'm going to move this brown bar up. They're exactly the same RGB values. Your conscious experiences are quite complicated and have all sorts of unexpected properties. Our experiences of color are highly correlated with an area of the brain called V4 and also activity in area V4A. If you have a stroke in V4 on the left hemisphere, you lose all color experience in the right visual world. It just goes to shades of gray. If you take a magnet and inhibit V4 on the left visual field, in the left hemisphere, you lose color temporarily in the right visual field. Take the magnet away, and color comes back. So there are tight correlations between neural activity and color experiences. And this is just one of hundreds of correlations that we found in the neurosciences. It's been amazing. Every conscious experience that we've been able to test has a neural correlate. And this has raised the scientific question: how does matter, perhaps neural matter, create conscious experiences? We have tons of data, tons of correlations between conscious experiences and states of the brain. So how does the magic happen? How does neural activity, for example, create conscious experiences? Well, this turns out to be one of the biggest unsolved mysteries in science today. And it's not a new mystery. Leibniz raised this question 300 years ago, and Huxley raised it in 1869. He said that it's as mysterious, how neural activity causes conscious experiences is as mysterious as a genie appearing out of a lamp when you rub it. So we still don't have any scientific theories that explain, without hand wave, how conscious experiences could emerge from brain activity. And this has raised some questions. It raises the question, can there actually be a science of consciousness? Can science actually address this question or not? We don't expect that monkeys have the concepts needed to understand quantum mechanics. Maybe Homo sapiens doesn't have the concepts we need to understand how matter could give rise to consciousness. And if we don't have the concepts, then maybe we can't do this. As Wittgenstein said, whereof one cannot speak, thereof one must be silent. Maybe we're forever blocked, because right now, despite tremendous efforts, there are no theories that make sense. And then there's the argument from a spiritual direction as well. Rumi said, silence is the language of God. All else is poor translation. So is it the case that consciousness, where science has been very successful, but when it gets to consciousness, it's gone beyond what it can do. It's reached the spiritual realm, and that's where progress stops. Now, I do respect someone who says silence is the language of God, all else is poor translation, and then is consistent and says nothing further. And that's not, I'm honest about that. I would really respect that. But that's not what happens, right? Tens of thousands of words in every spiritual tradition try to deal with issues, including consciousness. So, and we have conferences where we talk about it like this. So we're talking, there's lots and lots of words. So then Wittgenstein had something else to say. What can be said at all can be said clearly. And so, again, I respect complete silence, but if we're not going to be silent, then we at least should try to be as precise as we possibly can. So I'm going to talk about that. So what is science? Well, there's been a lot of work to try to figure out how science is different from everything else, and it's called the demarcation problem, and it's turned out to be very, very hard to define how science is different from other forms of inquiry. But I will just say that it's characterized by very, very careful observations and by precise, testable theories, and I would also say by the willingness to be shown that you're wrong. So you have precise theories that are precise not because you think you're right, so that others can tell you precisely why you're wrong. And that's sort of the spirit of science. So the idea is, if we're going to do consciousness and talk about consciousness, can we be very precise and try to be so precise that we can be shown to be wrong? Let's do a little thing about conscious experiences just to see what's going on here. Here's a conscious experience that you can have by looking at this image. And you might have some assumptions about the nature of your conscious experience. I'm going to flash this for a little bit. And do you notice anything strange about your conscious experience? Sometimes, do you notice a bush on top of the house disappears and then it appears? How many didn't see that until I mentioned it? Okay, you might go, how did I miss that? I mean, it's huge. Did you notice that this little patch in the grass appears and disappears? So there's a little patch here that appears. And how many didn't see that until okay? Well, there's more. There's a little bush there that appears, and how many didn't see that? Okay, so if you're surprised that you didn't see it, that means there are things about our conscious experiences that maybe are surprises to us, that we're not the true authorities about the nature of our conscious experiences. We can learn by doing careful experiments on conscious experiences. Similarly here, there's a big, big change. How many don't see the change? Okay, there's an engine that's sort of an important thing in the middle of the screen, right? So again, our feelings, we are not infallible about our conscious experiences. They have surprises for us. So introspection about conscious experiences is fallible. That's why we need to do science. And part of my background is in psychophysics. This is actually the science of studying conscious experiences and building mathematical models. Here's another conscious experience. You see a bunch of dots that are moving around, and they look like they're just in a flat plane. Now I'm going to change the movements of the dots a little bit. How many of you see a three-dimensional cylinder pop out all of a sudden, right? Well, I just changed the movements of the dots a little bit, and all of a sudden, you literally get a new dimension of conscious experience. A depth pops out. How did I do this? I actually know equations that determine whether you will see this thing pop out in 3 dimensions. In other words, your conscious experiences are not just these random things. We can write down equations that predict when your experiences will change from 2D to 3D. And that's what my field of psychophysics does. We do these careful experiments. We can write down mathematics that actually describes what you will see, the conscious experiences you will have. Your experiences are not just random events. They're mathematical. So conscious experiences can be described by mathematics. Another example, the top and bottom probably look different shades of gray. If you close one eye and put your finger over the boundary between them, you'll see that they're exactly the same. So once again, your conscious experiences can surprise you, and it turns out that mathematical computational models can predict this experience. And in fact, it's because we've been so successful at getting mathematically precise theories of all of our conscious experiences that virtual reality is now possible. In virtual reality, what we're doing is we're taking the mathematical models that we know about conscious experiences, putting them into a computer, and as a result, because we know with precision how conscious experiences work, we can put you into new worlds of conscious experience precisely the way we want. So virtual reality is actually possible because of this. We can also extend our senses in our conscious experiences with tools such as microscopes, or telescopes. These are the actual telescopes that Galileo used, that he built, and the lens that he built. Looking through telescopes today, which are a little bit bigger than Galileo's, we see things like this twin quasar. Two quasars that are about, 9 billion light years away. When you look at them, you have, of course, the conscious experience looking through the Hubble telescope of these two quasars, but when you look at it very carefully, you realize they're exactly the same distance away. The light from them is precisely the same, and in fact, there's nothing to distinguish them. They are the same object. And they really are the same object. So when you look into space, you have a double vision of a quasar. That's the conscious experience you have. And the question is why? We also, when we look deep into space with our telescopes, using X-rays and infrared and so forth, we can look straight to the heart of the Milky Way. And when we look really close, we see a huge source of X-rays at the very heart of our Milky Way, and bunches of stars moving around at millions of miles an hour around us. We find a black hole. We find a black hole right in the middle of the galaxy. And then we find that that's true of all galaxies, pretty much. And we even find, when we look through telescopes, we find double black holes. These incredibly massive things, they're spraying out X-rays at tremendous rates, whirling around each other. So these are experiences, conscious experiences that we have when we look through telescopes that extend our senses. And the question is why? Why are we having these kinds of conscious experiences? And Einstein explained it. This is why. This equation explains all of these conscious experiences. This is his general theory of relativity. It says the geometry of space is proportional to the distribution of matter, is affected by the matter. So geometry determines how matter moves, matter determines geometry. With that equation, you actually predict black holes, which Einstein did not like. Right? His theory was actually smarter than him. He, even as late as 1939, said black holes don't exist. He thought that they were just an artifact of the theory. So when you write down scientific theories, partly you do it because the theory ends up being smarter than you. And you can learn from your theory. That's the nice thing about a mathematical theory. Once you've written it down, you become a student of your own theory. It teaches you. Whereas just written words don't usually do that. So real quickly, what his theory predicts is that space can bend if there's something heavy in it, really massive. And it turns out with that twin quasar, there's a galaxy that's only 4 billion light years away. It's bending space, and the one quasar that's 9 billion light years away, its light goes around that gravitational lens, and we see double. So here's a conscious experience. You're looking through a telescope, the Hubble telescope, you see a twin quasar. How do you explain that conscious experience? You're going to need a lot of mathematics to understand that conscious experience. And that's the power of science with conscious experiences. So how can we then move forward with a scientific theory of consciousness? Well, I think both science and religion, science and spirituality, science and non-duality, have contributions that we can make to a new science of consciousness. But there are going to be challenges for science and for spirituality to do this successfully. Deeply held preconceptions are going to have to be let go to make progress, because the current conceptions aren't working. It's still a mystery. So here's the challenges for science. Scientists believe that space-time and objects exist even if they're not perceived. That's a fundamental assumption of most. They also believe that space, time, and matter are the right concepts to describe objective reality. And I want to propose that that's false. That's exactly false. Those are the wrong concepts. And I'll actually give a reason for why. So one reason why most scientists think that those are the right concepts is because we perceive the world that way. We perceive the world in terms of space and time and physical objects. And there's an evolutionary argument. We don't see all of reality, but those of our ancestors that saw reality accurately had a selective advantage over those who saw it less accurately. So we can be pretty confident that we're the offspring of those who saw reality more accurately. So our concepts of space and time and matter are the right concepts to describe objective reality. We might get things wrong here and there, not quite the right shape and so forth, but in general, our perceptions are accurate. That's the standard view. And it turns out it's false. When you actually look at the equations of evolution, evolution is a mathematically precise theory. We have evolutionary game theory, graph theory, and so forth. These are some of the equations. This is the equation of evolutionary game theory. When you actually analyze those equations, it turns out that there's a theorem. Whenever an organism that sees reality as it is competes with an organism of equal complexity that sees none of reality and is tuned to fitness, the organism that sees reality as it is goes extinct. In other words, natural selection stamps out true perceptions if they ever happen to arise. When I do simulations of genetic algorithms, they actually never arise. They're not fit enough to even get on the stage. So it's very, very clear. If our senses evolved and were shaped by natural selection, the probability that we see reality as it is zero. The probability that space and time and matter are the right concepts to describe objective reality is precisely zero. This is not just an idea, it's a theorem that was proven by Chetan Prakash, who spoke here yesterday. So now scientists have had some idea that maybe some of our perceptions are not telling us about objective reality. Galileo, back in 1633 or so, said, "I think that tastes, odors, colors, and so on reside in consciousness. Hence, if the living creature were removed, all these qualities would be annihilated." So he thought that like colors and tastes are not objective properties of the world, they're subjective properties of consciousness. But Galileo still believed that physical objects and space-time were objective. And I'm saying Galileo took the first step. There's another step. You have to let go of space-time and physical objects as well, not just color. So space, time, and objects exist only in consciousness. Now that's a bitter pill for most scientists. But some are coming along. So Nima Arkani Hamed is a professor at the Institute for Advanced Study at Princeton, working on fundamental physics, and he's come to this conclusion that space-time is doomed. There's no such thing as space-time fundamentally in the actual underlying description of the laws of physics. That's very startling because what physics is supposed to be about is describing things as they happen in space and time. So if there is no space-time, it's not clear what physics is about. And by the way, he's not upset about this. He's, with the right scientific attitude, he's really excited about this. This is fun. We're so deeply wrong. Our theories of quantum mechanics and general relativity that are assuming space-time are deeply wrong. That's fun. We're about to learn something, but we're going to have to give up space-time. It's fun. It's not fundamental. What is space-time, and what are our perceptions of objects? I think a good way to think about them is that it's just a user interface. We evolved a user interface. You know, your desktop on your computer, if you're crafting an email and the email is blue, the icon for the email is blue and rectangular on the right corner of your screen, that doesn't mean that the email in your computer is blue and rectangular and in the right corner of your computer, right? The interface is not there to resemble reality, it's there to hide reality and to give you eye candy that lets you do what you need to do. That's what evolution did. 3D space is our desktop. Physical objects are the eye candy. It's there not to show us the truth, but to hide the truth and to just let us act in ways that keep us alive. So space-time is not a fundamental reality, it's a data structure that we evolved. We're living in the matrix of our data structure. So when I open my eyes and I have a conscious experience that I describe as a red tomato a meter away, I'm interacting with something. But that something is not a red tomato and it's not in space and time. I've put digital rain there just to say it's something utterly different. Similarly, when I open my eyes and have a conscious experience of a lion, I'm interacting with some reality, but it's not a lion. And here's the kicker for the problem of consciousness. When I look inside of the skull and I have a conscious experience that I describe as a brain and neurons, I'm interacting with an objective reality, but that reality is not brains or neurons, it's something utterly different. the best I can do as a humble member of Homo sapiens is to describe it as brains and neurons. So brains and neurons do not exist unperceived. They have no causal power, and that's why we've never been able to boot up consciousness from neural activity. It can't be done because neurons have no causal powers. They're just useful fictions of our desktop interface. And then finally, scientists have to give up the idea that there is a third-person science. The key idea of third-person science is that you can look at this physical object, and I can look at this physical object. We can look at the same physical object, and we can both make measurements on it, and then compare. So we have this objective third-person data. But there are no public physical objects. Space-time itself is doomed. So all of science is first-person science. It can be rigorous, there can be comparison between different experimenters, but it's all first-person science. So science will also have to give up the idea of third-person science. And then finally, the idea that conscious agents are fundamental is a proposal that I'm making. This is a fallible proposal, but I think that we'll have to reboot science with a notion of consciousness that's rigorous, mathematical, and I've given a talk here in previous years about that. So, the theory that there was first the Big Bang, and then billions of years later came life, and then hundreds of millions of years later came consciousness, that story is fundamentally wrong. It's the other way around. Consciousness is fundamental. We need a mathematical model of it, and then we need from that model to boot up space-time and matter. And we can do that, but it's going to be some hard mathematical work. Now, challenges for spirituality. Everybody's going to have to give up on something here. It's not easy. So, first is to admit that maybe again, by the way, I could be wrong. That's the scientific attitude, but I'm proposing that consciousness can be described with mathematics. The only way to show that that's wrong is to try and to go down trying. So the proposal is to try. Can we come up with a mathematically precise theory of consciousness? And from that, boot up space-time and matter. So I think a science of consciousness is possible, a precise mathematical science, and that doesn't have to be a contradiction to human emotions, human aspirations. The two can work together. So again, science is about careful observations, testable theories, but there are no infallible authorities. Nobel Prize winners are not infallible authorities. Published books are not infallible authorities. Those are the next theories that we try to take down and see what's wrong, right? That's the way it goes. So, as Einstein put it, blind respect for authority is the greatest enemy of truth. So in this quest, we have to be careful not to give too much respect to authorities. I mean, we've seen what happens when authorities get in the way of science. Galileo actually had to recant his view about the Earth not being the center of the universe because the church said that Galileo had this heresy, that one may hold and defend as probable an opinion after it has been declared contrary to the Holy Scripture. So that's the blind, obedience to authority that we have to let go. That was in 1663. In 1992, the church apologized. It took 350 years. And we would like to move a little faster pace than that, right? It's a little bit faster pace. So the idea is to let go of the authorities. So scriptures and teachers can be sources of inspiration, but we have to not take them as infallible authorities. And for some, that might be difficult. Another aspect I think will be useful, but perhaps difficult on the spirituality side, is what Darwin proposed in his Origin of the Species. He said that psychology, including human emotions, will be based on a new foundation, that of the necessary acquirement of each mental power and capacity by gradation. He was saying evolution by natural selection applies not just to the body, but to our psychology, to our consciousness, to our emotions. And he actually, so there's a field of evolutionary psychology which for the first time gives us a science of human emotions, explains why our emotions sometimes conflict, why we have a sense of revenge, for example. It's very, very powerful theory. That will have to be part of what we accept as we try to understand human consciousness. So, can we have a science of consciousness? I think yes. I think that scientists and spirituality people can work together and bring our insights to have a very human approach and yet a very rigorous approach to understanding the question of consciousness, so we can finally understand who we are. And that's my hope. So science and spirituality working together can explore and, I think, understand consciousness. And with that, I'll stop. Thank you. Thank you. Thank you very much.